This
and their
conference will now be
application.
recorded.
We welcome you today on this webinar, Machine Learning Principles and their application. We are great to have such an esteemed presenter, Dr. Raghvendra Mall, who has done PhD in machine learning. He is a research scientist and he's currently working in one of the leading MNC in the world. He has done his bachelor and master in research from Triple IT Hyderabad. So thank you very much, sir, for your valuable time in this webinar today. So we all welcome Dr. Raghvendra Mall on this webinar, and we welcome you all also for joining this session. So as you know, machine learning is very important technology in today's world. It is the most happening technology. So let's hear from the most experienced person, Dr. Raghvendra Mall, on this topic today. So over to you, sir.
Yeah.
Please.
Okay. Thank you. Thanks a lot. I would like to first thank Career Guidance Council to give me the opportunity to present uh, brief concepts on machine learning to young graduates. I was told that the primarily the audience is mostly young graduates and uh, early stage job seekers. So I tried to make the presentation also oriented along those directions. A little bit about myself. I am Dr. Raghvendra Mall, as was mentioned earlier, and I am a research scientist at Qatar Computing Research Institute. It's one of the research institutions within Qatar. So there are three research institutions, and we are one of the national research institutes in here. And I have done a PhD in machine learning from KU Leuven in Belgium, but in here in Qatar Computing Research Institute, I focus more on computational biology and using data-driven techniques for important and like life-changing problems in healthcare. So let's start. Yeah, I mean, this is the starter slide which is presented in the provided in the template of CGC. So just I'm using the same template to highlight like what is CGC and vision for people who are, I guess, if you are joining the CGC for the first time. I mean, this webinar for or webinars organized by CGC for the first time. Okay, so the outline of my talk would be like I would try to motivate to you guys that. Why is machine learning, artificial intelligence, data science, these things are very important in the current era, and try to motivate you from every possible aspect that generally we feel are important. Then so this would be around like 15 to 20 minutes, 20 minutes maybe, and I don't know how it is organized, but the way I think that we should proceed is that I can present for 20-25 minutes, and then if you have questions about motivations, we can talk for questions, or we can like stop for questions for like 4 to 5 minutes. Then the next 40-45 minutes would be about concepts and applications. I would try to show you some basic preliminary concepts, easy to understand, and at the same time show several real world applications where machine learning and artificial intelligence are being used currently. After that also we can have like a 5 to 10 minute of question answers, and the last 10-15 minutes would be for resources, like what kind of resources are essential for all the things that I will be explaining in my talk, and we can have again a question answer session after that. So without further ado, let's start. So yeah, so the primary motivation is that we are currently living in the information age. This is aptly called the information age, and more so given the scenario that we are all right now in with the COVID-19 pandemic, that we are all stuck at home, and we are all are accessing internet all the time. So you can see that in every minute in 2019, how many Netflix views were there, or Instagram stories were put up, or how many YouTube clicks or videos were being watched. So we are living in the information age. You have we are our lives are almost on social media, and as a result of that, huge amount of data is being generated. I mean, from our conversations, from the emails that we send, from the clicks that we do. So there is a huge demand to for majority of these companies to analyze this data such that they can utilize it for various problems or various solutions, be it customer retention, be it looking up for how to acquire new customers. So they living in the information age goes hand in hand with analyzing whatever information that is being generated. So that's one of the primary motivations that exists. To show it further, there's another figure here that like our lives are all on social media. We are using Skype, we are using Outlook, LinkedIn, Twitter. I spend at least 5 to 6 hours every day on social media or various technological sites. So this is like, yeah, so as a result we are generating huge amount and humongous amount of data, and there is a need to analyze this data. And that's where like given that we have the advent of with the advent of modern technology, we can process this data. So we are able to there has been a resurgence of like machine learning and data science because of the availability of huge amount of data, or the we are living in the big data era. So, as I said, that you need to gain insights from the data that you generate. So that's why it becomes important to do data analysis, and this leads and builds on to understanding and making automated machines for doing such things. Like you need to understand. So the first thing that you do generally is do some exploratory analysis. You try to analyze what is the breakup of the population given your data, who are tweeting, which countries are tweeting. Like if you take the COVID-19 pandemic, you can see that even Google has an API where they show by demography like which countries has how many deaths. And so it's important to analyze the data that is being generated and visualize it, because for us as humans, the stimulus that we get by visual interpretation is very it allows us to understand the data that is being generated very well and draw insights out of that. So this is it's an important motivation to understand and explore the data that is being generated. And coming forward to, look, going forward with that, we have all heard this, that data scientist is the sexiest job of the 21st century. It came out in Harvard Business Review, and it's by two people quoted this, like Thomas S. Davenport and DJ Patel. DJ Patel was the chief data scientist at the United States Office of Science and Technology during the Obama time period of his presidency. So like from the White House also, it is coming out that data science, doing data science, doing machine learning is like the sexiest job of 21st century. So from the point of monetary point of view, or from a career point of view also, it is very lucrative to work in this domain. Yeah, so taking it a step forward, or even like going extravagant at an extravagant proposition, Sundar Pichai said that it is like artificial intelligence is more profound than fire and electricity. So you can see that it's not just national institutions that are doing that, or state offices that are doing it, but also technological companies are saying that. So Sundar Pichai, the CEO of Google, one of the biggest companies in the world. And then you have also people like Mark Cuban saying that I'm telling you, the world's first trillionaires are going to come from somebody who masters AI and its derivatives and applies it in ways we never thought of. So Mark Cuban is an American billionaire entrepreneur. If you have heard of Shark Tank, he's one of those guests who is on Shark Tank and keeps on acquiring a lot of startups and like funding them, in an angel investor. At the same time, he's also owner of Dallas Mavericks. So people who are even not within the technology field are also extremely motivated and are like can see the potential of artificial intelligence, machine learning, data science in general. Give more examples, AI and its offshoot machine learning, for particularly for machine learning, AI and its offshoot machine learning will be fundamental for creating social good as well as business success. So this is from Mark Hurd, the CEO of Oracle. And this is a fair point. It's not just that you get business success, but you do a lot of social good. Machine learning and artificial intelligence have led to the rise of fields such as social computing also, where people are analyzing data from Twitter, Reddit, and trying to see like how bipolar these platforms are, like where are there any people who are when people are fighting over these platforms, like how can we not just identify but also prevent such arguments, or even try to see if elections are getting rigged by analyzing data from such platforms. But in the healthcare domain, machine learning is being used to come up with solutions from radiology to understanding your genome. At every level, we are using machine learning to solve important problems for human existence, and for preventing diseases, and like understanding disease progression, coming up with cures, drug discovery. So it is heavily prevalent and is being used primarily because of the availability of huge amount of data that is generated in each of these fields. And another example is from what AI and machine learning allows you to do is to find needle in the haystack. So this is coming from United States Deputy Secretary of Defense. So coming from a Secretary of Defense, it means basically it is so even the defense organizations in US like CIA and DARPA and all, they fund a lot of research projects related to usage of machine learning for either it can be, I mean, so it can be related to terrorist related activities, understanding terror cells, or even understanding trajectories of missiles and all, such that how they can prevent global catastrophes before they happen. So you can understand, like, it's not just restricted to one particular field, but it is being explored in every possible field where you can, I mean, so machine learning is being used in every possible field where you can think of. So if you have a problem and you have enough data, you can use data driven techniques to find patterns which can be utilized. Another example can be cybersecurity, like modern warfare will be cyber based. So in cybersecurity also, people are using machine learning to do anomaly detection or phishing detection. So there are many applications which are like that. So I said three of these terms. I showed quotes about artificial intelligence, I showed quote about data science, and I showed quote about machine learning. But all three of them are heavily interrelated with one another. Machine learning is a complete subset of artificial intelligence as a concept, and then within machine learning you have deep learning, which is one of the concepts within machine learning. But data science is at the periphery of this, so it intersects with machine learning and artificial intelligence, but it has also some components which are not necessarily involved in machine learning, and we will see that what are such some of those components which are there. And at the heart of all this lies big data. So when we have big data, this big data is one of those things that is uh, making it possible for usage of machine learning and artificial intelligence in the modern era. So I hope that, I mean, I'm making the motivations clear to people, that why it is essential to work and like as young graduates or people who are thinking of doing higher education or being involved in technology or startups, that why it is essential that you get yourself accustomed to some form of machine learning or data science. So what is data science? So data science uh, has a component where you have the computer science part, where you learn how to code and all. But at the same time, it is also about heavy number crunching. So you need to understand maths and stats. And at the thing that makes it a little bit different from general machine learning is that you also use a lot of domain knowledge. You use business and domain knowledge that drives, so there's an iterative process, and that drives you to gain insights for the particular domain that you are working in. In machine learning, you can think of it as very abstract or a black box, where you have a given input, you want to get an output, and the model is doing that for you. But in data science, it's also heavily driven by the domain that is the domain in which you are working. So insights from that also help you a lot. So yeah, from a career perspective, what I did is basically I just did a small Google search on machine learning jobs in India, and I found, like, for 0 to 3 years experience, there are close to approximately like 3.5 k open positions which are there. Majority of the positions are in the in the cities which are upcoming, and like or are already are the metropolitan cities like Bangalore, Delhi, Mumbai, Gurgaon, Chennai. Surprisingly, Hyderabad was not in the top 5, but it was like in the top 10. And then you have all the companies who are, some of them who are just service providers also, or enterprises also. Everybody is looking for people like Accenture, IBM, Oracle. And what are the industries which are looking for it? It's financial services, software services, IT software, education. So I did a similar search on Indeed.co.in, and there I find that, yeah, the good thing is that you have other set of positions, but the companies which are offering these positions are a little different from those which are appearing on Naukri.com. And yeah, you see these companies like TCS, Wells Fargo, Vodafone, Amazon. I mean, name it. Every company is looking for people who are accustomed and who are learned with and have acquired some knowledge of machine learning as an engineer, because it is helpful for them when they're building their products. And on LinkedIn, there are, yeah, I did just this search like a couple of days ago. There are 6,451 positions in India as it appears on LinkedIn. Like a little bit more depth if we go from the career perspective, is that where I found this from a report given by LinkedIn, that some of the hottest roles that they have identified are like machine learning engineer, data scientist, based on what the recruiters are posting and what they're requiring. And India, like, you, in comparison to US, where a minimum degree that you find is very important is like the master's or the doctorate degree. In India, the bachelor's degree is sufficient. So young graduates are the ones who are entering this workforce and who are in heavy demand with some knowledge of machine learning, and who can be data scientists in companies. To further motivate, like, I did also a search, a little bit of search about like how much is the average salary that an individual who has some knowledge of machine learning, or can work as a machine learning engineer or a data scientist, can get in India. So on an average, the salary is also quite high. From low to high experience, it's pretty decent salary, given as a, if you are coming out of your college and you have good knowledge and you can work on machine learning products. That, I mean, it's a pretty good enough salary, I feel. And so this is from Glassdoor. I did a similar search on Payscale and found that, yeah, it's the numbers more or less make are coincidental, and they are very similar to one another. And like, what kind of skills generally these people are looking for, are like people who are getting these jobs have, are like they have good knowledge of machine learning, statistical analysis, big data analytics, Python and R are like the programming languages. So this is important. I mean, I hope this provides you enough motivation that why you should be invested in machine learning and data science in general, like understanding the concepts, applying it, making projects out of it, and learning these technologies. So a further thing that I found is that what would be the demand in the coming years. So it seems like, yeah, there will be. I mean, right now there is a huge amount of hype. In the coming years, 5 to 10 years, the hype will still keep on continuing, and there will be increasing demand till it reaches inflection point and it comes down. But this is like a cycle, like anything. Like any technological advancement, there are cycles, and this is also like a cycle that after some time, that once the demand goes down, it will resurge. And this is exactly what we also observed in machine learning. Like, one of the concepts that I will talk about, like artificial neural networks, you will see that it was extremely popular in 1980s, 1990s. It fell down for 20 years, and after 2010s, nobody looks for anything else apart from using neural networks and deep learning for building whatever technological product that they are doing, like right now. So these kind of cycles will happen, but there is a huge prospect for the coming one, like 10 years, that there is going to be increasing demand for people who are data scientists or machine learning experts. Yeah. And again, so I showed you about some of these companies, but at the same time, you have to understand that machine learning is also about invention, trying to come up with new technologies. And who better than the tech giants in the world to push the frontiers? So Google has applied for nearly 300 AI-based patents only since 2009. Microsoft is just behind Google with 270 AI patents. Amazon and Facebook have 70 plus patents. and IBM has claimed that it has won over 1700 AI patents till 2017, so making it one of the making it the company which has the got the maximum number of patents related to artificial intelligence applications. And China recently has surpassed US in deep learning patents. So you can see that there is this competition also which is going on. US and Silicon Valley, which is thought to be the hub of everything, is now being overtaken by China. Companies like Baidu, Alibaba, and all are recruiting heavily experts in machine learning from US, and then trying to come up with products and ideas which they can patent using machine learning and artificial intelligence technology. So some of these institutes which have specifically like from people who are thinking of becoming a machine learning engineer, they some of the best places in the world are just opening labs for that particular purpose, like Uber AI labs, Alibaba AI labs, Google AI, Microsoft DeepMind, IBM Research, Amazon AI. So people who are not just undergrads or who are young graduates, but people who have done PhD and all can also find a safe haven in these particular technological labs where they can continue doing research, but at the same time work on research that is more product or product focused. So but at the same time, I mean, young as a young engineer, when I finished my to give my experience, I got an offer from IBM Research to become a machine learning engineer when I finished my masters. So though I wanted to pursue higher studies, but if you do a master's in machine learning, you can get a job also in one of these premier institutes, which yeah, I mean, one of these premier organizations which are there. Apart from that, nowadays there is a resurgence of setting up your own companies. So you can see that there are all over the world. I mean, there are many startups and which are AI focused. So that's what I was trying to show here, that this is from the observatory of public, sorry. Yeah, just a second. Yes, I mean, it's one of from one of those government organizations, and what it is trying to say is that what this figure is trying to depict here is that there are many nations which are already AI strategy is complete for them. So like they are already basically compliant with what the government policies also align with uh, allowing AI startups, funding AI startups. So there is this resurgence. I mean, not just research. I mean, there is this. Uh, in a way, there is a resurgence of like people who want to set up their own companies. There is opportunities for them also, and that's what it leads to. Going a little bit forward, there are also national institutions which are there, like QCRI, as I mentioned, which are focused just on coming up with AI-based technologies and making their, I mean, solving problems in the public sector, not necessarily in the private sector, but in the public sector or public problems using like at their heart using computer science and artificial intelligence technologies. So such institutions are like QCRI, there's NITRD and NSF are US based organizations. They fund a lot of projects which are like that. RIKEN is from Japan, KAIST is from Korea, India is from France. Then you have Institute of Science and Technology. Questacon is from Australia. NIST is in India. So that's the National Institute of Science and Technology in India. So people can also find like academic safe havens for them who want to work in uh, public sector problems, like me, for example, who is working in Qatar Computing Research Institute and working on local problems, but at the same time working on challenges like cancer which are at a global level. So we also find opportunities in government organizations. So yeah, here, as I said about the Indian ecosystem related to like, yeah, I mean, so startups. So you have fintech, healthcare, transport, and retail and e-commerce startups, and majority of them are AI compliant. So you can see that they are the global AI startup distribution, and you can see there are more than 169 startups in India, which are coming up with technologies which are AI based, and there's huge amount of investment going on everywhere in the world. So India is one of the hubs, but there are many hubs in Europe. That's one of the interesting things, that in Europe as well as in US we all know that Silicon Valley is there, so there a tremendous amount of startups. But there, I mean, it was sort of surprising for me was that there's huge amount of investment going on also in Europe. Traditionally in Europe, most of the investment go to academic institutions, but people are becoming more and more focused towards having their own companies and making them AI compliant.
Life's not clear.
So yeah, to just give an example of some of these startups in India, which are also good opportunities for people like who are finishing their, who have done a course in
Engagement career
machine learning
opportunity.
or artificial intelligence, uh, who can join some of these companies are institutions like Haptic, Avamo. These are conversational based startups where basically they are trying to come up with technologies which can basically handle speech recognition. I mean, problems related to speech or translation, or automatic bots. Then in the healthcare domain, you have Niramai and Doxpert. Niramai, I think, is related to breast cancer, trying to come up with technologies which are machine learning driven for doing breast cancer like diagnosis as well as solutions better. You have logistics company like Loginext and Locus, and fintech you have RubyQ and Lending Card, and for agri ecosystem you have Cropin and Fasa. So just to give you an idea, I mean, of the broad spectrum of areas where machine learning is making its predominance felt and is being used to come up with cutting edge solutions. That's basically the idea. So I think with that, yeah, I kind of end up the motivation section. And if you have any questions, I guess I can take them right now for like 5 minutes. We can talk a little bit about it. Uh, or we can take it at the end as you guys prefer.
Yeah, thank you very much, sir. I am Shuim from Career Guidance Council team. So I request everyone, if you have any question to, so please ask on the chat window, because we can't unmute all, otherwise it will be a lot of noise and disturbance. So I request everyone to please post your question on the chat window if you have. Thank you very much, sir. It is very inspirational, and the information which you have shared, I hope it will be very inspirational to all who have joined this webinar. Thank you so much.
Yeah. So I would like the moderator if the moderator can ask like couple of questions out of those, or two, three questions, I can answer them if there are any questions, or just let me know, I can move forward also.
So, sir, what is the basic skill set is required? Like as you told that in India, having bachelor degree is also enough. So, if a particular person just do some courses and do some kind of small projects on machine learning, so is that enough to
So
have
I
that
mean,
qualification and apply for the job?
So I think yes. So that's a very good question, and I guess it will be answered in the coming slides that I present when I talk about it in the resources part. But what I feel is that yes, exactly. I mean, doing in your bachelor's, you should ideally take up a, like we used to have a BTP, so like a final year project. So you can take up a couple of projects which are related to machine learning. You can learn skills like programming languages like Python and R. Mostly Python. Learn skills like how to make models for deep learning. Make GitHub repositories, open source repositories, publish your code such that people you can just put it in your CV and people can see that you have open source code which are available, and people can check it, reproduce your results, do projects which are projects and internships which are working on real world applications but have a machine learning component involved. So these are some of the suggestions that I generally give to my students also, and that's the same thing. But having a bachelor's is sufficient. Why you generally try to pursue a master's, or generally companies look for master students, is because then they have done heavily focused courses related to machine learning. In bachelor's, we are taught a wide spectrum of courses, but when you have a master's, in general, you do 1 or 2 years specifically focused on machine learning projects and courses. So that basically helps to tune you or maybe make you sharper. So that's the thing. But at the same time, as a bachelor student also, I feel like you can do those in your free time in parallel also. So we have to keep up with the other, I mean, so we have to keep up in general. So I guess I hope that answers the question.
Yeah, yeah. Thank you very much, sir. I see participant are posting the question on the chat window also. I see 5, 6 questions. So can you please check and see?
Okay, I
Uh,
can check, and yeah, or yeah.
yeah.
So okay, okay. Okay, so yeah, I take the questions one by one. So people are saying linear programming. So I guess Ahmed has asked this, that linear programming and optimization, what is the best source to learn from? I will be explaining that in the resources part. Uh, I would be, I mean, yeah, if you wait a little, I will explain that in the resources. Some of these questions will be answered later on. So I'm not answering them right now, but they will be part of our slide. I mean, my slides, you can see that later on. Do we need a degree in AI, or just doing some short courses enough to join as AI engineer? So ideally, if you have a master's in AI in your bachelor's, or in your bachelor's you have taken courses related to like machine learning offered by your institution, or from many of these online courses which are available, but from a reputed academic institution, that can be very helpful for you. But doing a master's shows that you have more focused work for a prolonged period of focused time on a particular, in a particular field, and that kind of adds value to your CV. So the question from Pratibha is that which institution is best to go for training in Hyderabad, and what will be a fee structure? So I've been out of India for 10 years. So I won't be able to answer about the fee structure, but in Hyderabad, I think if you are Triple IT is one of the best institutes. It also has a good incubator center for startups. And also I guess the University of Hyderabad itself also very good. So at least these two places are good that I know of. How to get started to become expert? There will be some ideas that will I will present in the lecture a little later on, and you will be able to get that from the resources part. How machine learning is useful in finance domain? So that's a good question. I can give an example, like for doing stock market prediction, right? You have information about a stock over a period of time, but that stock itself may be influenced by other stocks because it has correlation with others. So take an example of one of the blue chip companies, like say Infosys or something. So if I have this data, can be considered as a time series, and if I consider just the data uh, of Infosys, like I have over a period of time, I can collect it from, there are many places, moneycontrol.com, or where I can get over a period of time how did the stock perform, and I can take a few other technology companies along with that. That becomes basically a matrix where I have information about not just Infosys, but I have information about other companies which are also related to say it, or are in the same domain, right? Now, if I want to predict what would be the stock price tomorrow, I can use all this information and pass it to a machine learning model, which can then tell me, not necessarily very accurately, otherwise, I mean, everybody would have been rich and famous. But you can pose this problem as like predicting the stock price for a particular stock next day as a machine learning problem, and have good solutions for that. So this is just one example I am giving you. There are many other examples. Like it, we are ourselves also working with some fintech companies on analyzing or understanding different kind of charts which are there in finance domain, which can or do sentiment analysis, news based analysis to predict stock predictions, or come up with a optimized portfolio using machine learning. So there's tremendous number of applications which are there, or doing algorithmic trading, for an example. Can we start machine learning research after having 4 years of job experience in IT domain, a business analyst? Yes, of course. Why not? I mean, actually, that adds value to you because you are very well accustomed with the IT domain. So if you do a couple of courses, make good projects, and highlight yourself, as I will explain in the resources part, how you can highlight yourself and do good projects, be part of some competitions, you can get a very good job in as a machine learning engineer also. What qualifications you require for machine learning, this will also be explained a little later on. What would be basic role for machine learning person, will it be developer? So that's a very good question. I mean, so as a researcher, I see myself as a researcher. So there are many ways in which people can be involved in an organization. So you can either be a developer who is doing as an engineer who is making the product using agile technologies and all, or you can be someone who is basically doing the prototype, like someone like us who come up with a solution, who have to do innovation, because machine learning also allows you to do a lot of innovation. So who come up with the innovation, and at the same time then work in parallel with engineers who make the product. So you can be a developer, you can be a researcher, you I think there are multiple ways. You can even be a manager at the same time. Like when, for example, I have a manager who is an expert in machine learning and at the same time manages other machine learning engineers or researchers under him. So there are many ways in which you can be or positions you can have as someone who is an expert in machine learning. Where to start in machine learning? For last 5 years I've been handling machine learning projects on operational front for Google. This question is a little specific. Handling, I don't have a right answer right now for you, but maybe as we go along I can think of something and maybe answer that. Any good institution, I have already answered this. How a person who is from a non-technical background can jump into machine learning career, what kind of programming language is required? I explained that also. So I can give you example. This is sad to everyone. He's asked this. It's a good question because even people who are from finance domain, like from audit background and all, I keep getting these questions from them that what kind of like knowledge do I need, or how programming seems very difficult to me, how can I do it? So there are these online applications which allow you to learn programming and at the same time do machine learning in a much more easier way. You Programming is all about logic, and if you understand basic logic, then you don't have to be afraid about it. But of course you have to learn it to do any kind of machine learning. Yeah, I mean, there are abstract platforms also which are there, but it is good to understand basic concepts in general, to and get a little bit of technical knowledge before you try to delve deeper into a machine learning career. So I would say that you need to learn a little bit, but at the same time you can use many resources which are available for people who are non from a non-technical background also. It is required to be proficient programmer to start with ML. I guess part of it is already answered. You need to be a decent programmer to start with ML. I mean, can mechanical students do this course? Of course, you can do it. I mean, anyone can. I mean, I think as long as you can understand little bit in mechanical also, you have to do optimization, and you do a lot of engineering. You have a lot of engineering skills. So I don't think that you cannot do it. You can definitely do it. How PG can be pursued in Hyderabad and after BCom. Exactly. I think you can do masters. There are masters course offered by, I guess, Triple IT and University of Hyderabad that I mentioned earlier. So I think yes. I guess I've answered a good lot of questions. Let me go back to the slides and try to explain a few concepts, and then we can again come back to, when I explain the resources part, we can come back to your questions. Would that be a good way to go about it?
Yeah, I think it will be better, sir.
Yeah.
At the end also we can take this questions.
Okay, cool. So yeah, let's start for the second part. So to explain, we have talked a lot about artificial intelligence, machine learning, data science, but you need to understand what it is at the heart of it. What does it mean basically? So AI originated as a description of human thinking as a symbolic system, programmable or digital computer based on mathematical reasoning, invented in 1940s. So that was the first time when you had a system which was based on mathematical reasoning. And the term artificial intelligence was coined by John McCarthy in 1955, and the most of the AI research is centered or is based on is based and is inspired by the human brain. Like in our brain, we have neurons, and these neurons are interconnected, heavily interconnected with each other. Every decision, every function that we perform is driven by electrical impulses that are happening in this synopsis, or in this combination of these neurons. So machine learning and artificial intelligence itself was also heavily inspired by that. That you can our brain be mimicked. So that was the problem that was posed, or the hypothesis that was posed, and the field of artificial intelligence was built based on that. As I mentioned to you earlier, 1970s and 1980s were the glory era of artificial neural networks. A lot of applications started to appear where people were able to show that you can use these neural networks, which are inspired by the human brain, to solve problems. Some of the examples are like driving the vehicle and following the
Understood.
trajectory of the road. uh, and then, but one of the problems that emerged during that era was the limitations in computing power. So you have huge amount of limitation in the computing power, because most of these models that, or the neural network models, are heavily data driven and are resource dependent, computationally heavy. They are very heavy from a computational point of view. So uh, the systems of those era were not able to handle the amount of computations that you had to do, or the prolonged amount of time that it would take to perform those computations. So that led to research. That led to the decline of AI after the 1980s, and other techniques started to appear which fall in more the machine learning branch, uh, and as we will see a little bit in detail. So yeah, so AI initially was restricted primarily to research labs, and machine learning became popular in the era from 1980 to 2010. So these is not the as I said, like when the AI bandwagon started to fall, people started to focus on more simpler and less denser techniques from a computational point of view, and that was what led to the development of machine learning technologies at that time. And with the advent of modern supercomputers and GPUs, there has been a huge resurgence in AI again, or artificial intelligence, or in particular the field of deep learning. So that's what it's coming to the next point, which is like in 2010 and after that, deep learning became the focal point of modern AI researchers. So that's what most of the applications right now are using some form of deep learning or the other, and it's because it outperforms, or it performs at par with most of the other machine learning methods which are there. So this is basically the life cycle of it, that you have from 1950s to 1970s, neural networks are predominant, but after that it led to resurgence of tree-based techniques, convex optimization-based techniques for machine learning. But in the present day, we are again in the era of deep learning. So just to understand a little bit more, fundamentally AI is collection of mathematical algorithms enabling computer to understand correlation between various data elements. And that's it. You have data, it tries to understand the pattern within the data to perform a particular task. This is what uh, right now the true definition of AI. I mean, in the current generation, the definition of AI is it's or the computational models that we build are doing. So AI driven machine perform tasks mimicking human intelligence. However, true intelligence goes beyond what is mechanically possible. So we are not at the stage where AI can start to think itself, or I mean, it can be truly intelligent, whatever be the meaning of truly intelligent. So we are not in the era where you can have Terminator coming alive. So just to be sure, we are just building systems, machine which can mimic human intelligence, or which are programmed to mimic human intelligence. That's all we are at right now. So coming to machine learning, so machine learning was the term that was coined by Arthur Samuel in 1959. And subset of AI, as I mentioned, huge amount of data is required to train models, and knowledge gain can be extended to previously unseen data. So that was the thing that basically drove the machine learning community. That you have a model that you have trained on a particular data, but now when you have new data coming in, your model should be able to generalize to this new data, and you should be correctly be able to predict for this new data. To give an example, a simple example would be like, if you have to differentiate apples from oranges, you take 10,000 apples, random set of 10,000 apples, random set of 10,000 oranges, and build a model which can differentiate apples from oranges. And then now when you have a new place and a new location, and you start to collect apples and oranges from that, your model should still be able to differentiate the apples from oranges. It's very easy for us as humans to differentiate apples from oranges, but just by visual cues. But for a machine learning model to learn this, it needs a huge amount. It needs good amount of data to learn this. That what are the features that differentiate an apple from an orange? It can be the color, it can be texture, it can be the shape. So many of these features it learns, or you provide as input to it. So that's basically what are the kind of things that drive machine learning models. So, and coming to data science, as I said, that data science, so this figure kind of explains the entire data science process. That you start from this phase where you do data cleaning. So you collect data. I mean, you have data acquisition, you have to collect data for a particular problem. So suppose you have to collect data for Twitter to do sentiment analysis. Like, you have taken million tweets and you want to see how toxic are these tweets. I mean, are they toxic, or are they in favor of something? So they are positive or negative tweets. So you collect data, you clean them, you have to transform them such that they are machine readable, and then you start doing the exploratory data analysis part, where you define the selection of feature variables that you will use to build your model, and then you do the modeling using methods that have been developed by people to differentiate what is a positive tweet from a negative tweet, for example. And once you have done that, you visualize your results. So these are the parts which are generally not part of the machine learning cycle. The primary part of the machine learning cycle is doing the exploratory data analysis and doing the data modeling. These are the two primary components of it. But the other things are like the gaining the insights that you have got, and why, answering questions like why, what happened. These are not necessarily components of the machine learning. Some people will say that it is component of machine learning, but in general, the primary thing which is associated with machine learning is the exploratory data analysis and doing the modeling. And this complete scenario is what is called is the basically the process involved in data science. So I hope it helps to make the distinction a little bit clearer. Coming to the concepts in machine learning, so there are three primary concepts in machine learning. You have supervised learning, you have unsupervised learning, and you have reinforcement learning. So these are the three primary concepts which have driven most of the technological advancements, or most of the technology that you see, or the applications, real world applications you see, are based on these three areas only. Primarily based on supervised learning, you will see. And to give a more elaborate explanation of that, so you have machine learning, and machine learning you have classical machine learning, and within classical machine learning you have unsupervised and supervised machine learning. In here, the tasks are like classification and regression, which are basically you have labeled data, you have information about. So in the example of the Twitter example that I gave you, you know somehow you have manually annotated. So from Twitter you get completely unstructured data. Your data is unstructured. You have to first convert into structured data, and once you have converted into structured data, what you have to do also, if you want to do the sentiment analysis I just suggested, uh, you need to have label for each of the tweet, whether it is positive or negative. So some of the ways that people can get these labels is people manually annotate them. You hire a behavioral expert or a set of behavioral experts using the mechanical turk, and they annotate these, and then you take a consensus of their annotations or their votes to say, oh, okay, this tweet is positive or is negative. Once you have that, then when you have these label information, then you can build models which fall in the category of supervised learning. But if you want to do unsupervised, I mean, if you wanted to handle the Twitter data as it is, and based on the data itself, without doing this labeling, if you wanted to analyze this data and try to see, like, are there such groups of people who are saying similar things, or groups of tweets which are saying similar things, you can do things like clustering, which falls in the unsupervised category. And you can also do other things like dimensionality reduction to do the visualization. You can do the visualization of the data. So and to analyze, like, where does the tweet fall basically. So I mean, if in order to see are these to do the visualization and the exploratory analysis, you have techniques of dimensionality reduction. uh, So this was about the classical learning, and then you have also the area of reinforcement learning. So reinforcement learning, what basically is that you most of the modern AI that you see in games and all, they are based on reinforcement learning. So you have a state, you are currently in a state, and you perform an action and you get a reward based on that. So for example, you are playing the game of Super Mario. You are at a particular position, you take a coin, you hit one of those obstacles and you get a coin. So you can see that your state was that you was at a particular position, you did an action which was you hit a particular obstacle, and the reward was that you got a coin. So based on that principles, reinforcement learning, the idea of reinforcement learning works. And it is used, I mean, what is said is that this kind of model are closer to what human thinking is, because there is a feedback loop going on, that you get a reward based on every action that you perform. So there is a feedback that you get from the environment. So as a result of which, you can think about it like there is little bit of information that the model gets, and that allows it to have the capability, a little bit of capability, we can say, I mean, I'm just making an analogy of thinking in a way, because it performs an action and gets a reward, and based on that, whatever goal it has to achieve, it will try to come up with the optimal strategy or trajectory for that. And then of course you have the area of neural networks and deep learning, though they primarily fall into supervised and unsupervised categories. That's what I am highlighting here through these arrows. But you have the complete area of deep learning. We'll explain this a little bit in more detail, but here are some of these models which are associated with deep learning. So coming to classical machine learning, as I said that in classical machine learning you have supervised, which is classification and regression. In classification, you just do the differentiation, that differentiate apples from oranges. In the case of regression, I would do something like the stock market value prediction for a particular stock. Whether what would be the if I want to do the prediction for a particular value of a particular stock, like the example of Infosys that I gave, what would be the value net tomorrow? This would be like a regression problem where you try to estimate the value, and it's not just whether it belongs to positive or negative class or some classes. In the case of unsupervised learning, like the example of clustering that I gave, then you can also have example of dimension reduction. This is used for visualization, and at the same time for recommendation purposes. You will see examples I will give later on from techniques like companies like Amazon and all are using, and they do use dimensionality reduction or SVD based techniques. And then you have techniques related to association analysis, where basically what you are trying to do is market basket analysis. Like, if I buy bread from a supermarket, would I buy butter also, and should I place bread and butter together or not? So these kind of ideas also, these are called association learning, that what kind of products to place together, because these kind of products people purchase together. So it's based on association learning. So examples of supervised learning. So I told you that we will give you a lot of real world examples without going in too much detail of the methodologies as such. But you can see the examples of supervised learning are like spam filters. So Microsoft Outlook is using it. That how like trying to differentiate something which is spam from non-spam, like a mail that is important versus a mail that is coming from an erroneous source. For language detection, Google Translate uses it to differentiate different languages based on just the text that you have typed, what language it belongs to. Search similar documents again in Google search, that if I have a document and I want to find other documents that are similar to it, I can use it as a supervised learning problem. For sentiment analysis, as I gave examples, Twitter, Reddit, LinkedIn, all these companies are using machine learning techniques for solving these problems related to sentiment analysis, to identify how bipolar certain communities are within these platforms. Uh, then recognition of handwritten characters and numbers. So US Post, it is one of the first examples that we learned from in supervised learning, is that the US postal system, it was using machine learning techniques to identify what are the different handwritten characters uh, in the letters that are there. So this was one of the first applications of modern machine learning. Then again, you can use it in fraud detection, like people for credit risk, or like banks and mobile companies can use it for detecting some when a message is being sent, is it a fraudulent message or not, or is it coming from the bank itself or not. So for fraud detection also you can use it. Cybersecurity applications also. So just giving a simple example of the spam versus non-spam. So like, yeah, if you have a simple like simplest spam filter can be that you say all the words, you have annotated certain words to be positive and certain words to be negative, based on the set of samples that you have. You collected a set of say 10,000 or 100,000 emails, and based on those set of emails, you took the count of each of these words which are good and bad, and then you annotated them, and based on that you try to come up with a probabilistic model which says that, okay, if I have multiple bad words appearing in my mail, it is a spam. So this is the simplest possible model that you can see based on the frequency of a word that is appearing in the uh, in your mail. So your spam classifier will work. Sometimes these models don't work because here it consider each word independent of the other, but and people can cheat the system by putting in your spam several good words. So yeah, all kind of problems can exist, but this is the simplest spam filter. We can come up with more advanced spam filters where we can analyze the sentiment which is associated with that mail to differentiate a spam from a non-spam. So another example of another model is to of a decision tree. So like this example can be used in a company which is giving, for example, in a bank which is giving you credit loan. So it will look at your credit history. If it sees that, oh, your credit history is bad, or you have made a pledge or not, and are there any guarantors, based on that it can say that, okay, it will follow this branch, and based on that it will identify whether you should be applicable for giving a loan or not, you are good enough candidate to get a loan or not. So to learn this particular branch, the model builds these trees based on the set of samples that it has seen from huge amount of data that the bank has collected from all its past loan applications, and then it builds these trees, and based on that tree it can say with some confidence who I should give a loan or not. So this is example of supervised learning which can be easily be used in a banking system right now. We might not know about it, but it is happening. Then, yeah, the example that I gave you of apple versus oranges, the same thing applies. I mean, so here, I mean, I'm giving you an example of bagging, which is one of these techniques in supervised learning, where you make different sets of data from a. So what you do basically is that you are given a big amount of data, and you take subsets of this data, and from these subsets of the data you build models, and then you aggregate these models. And when majority of the models are saying that okay, this particular fruit that you're looking for is an apple, then it will predict that okay, this is an apple. So based on the majority vote of the multiple trees that it has built, or the classifiers it has built. So this is what I mean. Yeah, is another technique in machine learning that we that is very popular. Like it's called bagging, and yeah, just giving an example of that. But you can think that if you come up with a like an idea where you have a farm and you are producing a lot of vegetables, and now you have a conveyor belt. You don't you usually you will manually pick up the fruits and then put them in different baskets. But now if you can think of a system, an automated system where you have a conveyor belt, you put all these uh, fruits on this conveyor belt, and then from this conveyor belt it automatically differentiates which fruit. By taking a picture of the fruit, it can differentiate which fruit belongs to which particular basket, and can automatically segment these different fruits which are there for you. So these kind of techniques are already being used by organizations like Walmart Labs. So in Walmart, it is being used already. Just giving you an example. And then you have also techniques like boosting, where what you try to do is that, like for the same example, you try to build the model, and then whenever a model make mistakes, you focus only on those cases where your model was making a lot of mistakes, and you keep on trying to perform your model. You rebuild the model, you keep on trying to improve, such that in the end you keep on doing it till your model have very less errors. And so that's why I mean, so you can always have the problem of overfitting, that you build your model very much to be working for a particular set of data, but now when new data comes in, or when you have new set of fruits which are appearing, the model differentiate very well what are these fruits. So your model should have good performance on your training data, but at the same time should generalize to new unseen data also well. That's when you have a good machine learning model, and it's one of these important concepts in machine learning, that you should have good generalization. For doing this good generalization, generally we have regularization, like we penalize our models when they are overfitting a lot. So some other examples are, for example, predicting traffic jams. Like if people live in Hyderabad or in Bangalore, they definitely know that this is a big problem, that you have traffic jams. So if I can see that how many over a period of time, I take a period of time, I seen how many vehicles are there, or the amount of time it takes for in a particular hour of the day. I can plot it, and I can see that if I want to predict when will be huge traffic jams, and what are the hours of peak traffic, I can fit a model. Here if I fit a linear model, I have more errors, but if I fit a polynomial, I have much less errors in my model. And this is where so when you try to fit this particular line, or they understand estimate this polynomial, this is what is a regression problem, because you will then, based on this, when you have a new sample that comes in, you can predict that okay, at this particular hour, this much would be the travel time it would take, and you're predicting a value, not necessarily differentiating one thing from the other. So when you try to predict a numeric value, this problem is more in the regression side of supervised learning. So concepts of and so coming to unsupervised learning, you have concepts like clustering. So exactly the thing that I gave the example of, that can I differentiate different food items from one another, or segment the population that exists, but without knowing any information about each I mean, without having labeled information. Like I don't know what this is, a sandwich, and this is a pizza, but at the same time they have characteristics which are similar to one another. So can I put them in different clusters or not? So this is where you do it in an unsupervised framework when you don't have labels. And some of these applications are like market segmentation. So e-commerce companies use it to differentiate people who have similar interests, such that they can recommend products to them by looking at their age, their hobbies, their interests, what they have clicked on. So market segmentation is being used in e-commerce companies, digital marketing, image compression. So Apple and Google Photos, they use a lot of image compression by compressing all you generally when we take a selfie, we don't take one selfie, we take like 15 or 20 selfies. And then what image compression allows us to do is basically it knows that all of these are just the same person and it's a selfie. So why use all the space of the 20 images? Why not I just compress them and put it in one image? So that's image compression example that Apple and Google Photos do use. And they are using underlying concepts of clustering, that clustering and identifying what are images are similar to one another. Then detect abnormal behavior. Intelligence agencies, like for example, when you have a cybersecurity problem, most of the like all your packets that you get from particular IP in general, they follow a pattern. But when you find that there are some patterns which are abnormal, so all the patterns which are, I mean, the packets which have similar pattern can be clustered together using again unsupervised learning techniques. And then if you have something which follows an anomalous pattern, you can identify because it does not follow the general pattern which is there. So to detect abnormal behavior also, you can use unsupervised learning. You can use it to merge close points on a map. Google Maps is using it for doing network analysis, like to identify communities of people who are like-minded, have similar behavior. Facebook uses unsupervised learning to suggest friends to you based on other friends you have, common friends. So many of these top tech institutes are using methods related to unsupervised learning for their products. For dimensionality reduction is also used for recommendation systems. I'll give some examples later on. And association rule mining, as I suggested, that if you buy bread and do you what and you try to buy, I mean, you look at patterns of people who are buying things at supermarkets, and then you identified that there are tons of people who buy bread and butter together. So ideally, I should, when I place things in the supermarket, I should place bread and butter close to one another because people tend to buy them together. So how to put things or resource management, you can do it also with unsupervised learning techniques. Yeah, so this is example of like, yeah, it's a funny example, but at the same time you can think of it that this example can also be used for, say, a telecommunication company which wants to set up towers and wants to identify what are the places in a particular city where I should set up my mobile towers. So initially it can try to identify dense locations. It starts with a random set of locations. Say it has resources only to put three telecommunication towers, and it starts randomly. And then what it tries to see is that what are those positions such that I can reach maximum amount of people and get maximum coverage out of it. And using a technique like k-means, it can identify this is an example of a k-means technique. Iteratively it works. It looks at the errors that you have by picking a particular location and like how much coverage you can reach, and based on that it keeps on trying to update itself and try to move towards the center of dense locations. And this is what it will exactly do. It will move towards the center of dense locations such that the coverage maximum. And now if I want to identify and put a fourth one, I can start again with a random point and then identify that place where the location is dense. So it keeps on working till you have identified the optimal position. So you can, I mean, the example that I gave you, you can think easily any of these telecommunication companies, if it has a map like this, can utilize it. So this is again a real world example. So yeah, I mean, in here I'm showing you an example also. I mean, this is a simple example of another method where it tries to identify like the different set of dense points which are there and differentiate it from the anomalous events which are happening. And you will see that it will identify the dense clusters or the dense set of patterns which keep on appearing, this method is called dbscan, and then yeah, you can see these are the outliers which is just highlighted very fast at a certain point of time, which do not follow the general trend of pattern for this particular application. So this can be, for example, a security threat. It can identify those which are security threat because they don't follow the general norm. So coming to the recommendation engines, most of these engines like Amazon, YouTube, or e-commerce agents in general, they use something called singular value decomposition to identify like groups of people and who have similar behaviors, or in the sense that who have similar tastes. So to explain this, it's much easier to explain it by an example. You have people here, you have like some of these particular terms which are present in documents, and here you have some documents. Now what you want to do is that you want to cluster these documents which have terms which are appearing multiple times or similar terms, and you can see that these clusters are appearing here. You have these terms which are associated with screen, laptop, program, mouse, loop, Linux. So you can see that in these documents you have all of these terms which are appearing simultaneously. So these documents are very similar to one another based on these terms, and this basically would associate with someone's search related to, say for example, who is looking for buying a new laptop which can support Linux. Then here you see this cluster which is associated with health, diet, someone who is searching for say a good healthy diet to follow. So this is how what the search results would look like. The documents that are highlighted here would appear from some search engine like say Google, that would be there. And as an example, I was when I was doing my internship at Microsoft Research, we were working on a very similar problem, that exactly some of a problem like this, trying to identify micro markets. So what we had is that we had keywords and we had advertisers. Advertisers bid on these keywords. So we know that there are some advertisers who are more interested in finance related stuff, who are more interested in car related stuff, and they bid on keywords based on that. So our goal was to identify keywords which are similar to one another, such that I can do the auto completion task. For example, when you're typing a keyword, like you're typing Mercedes, I would automatically complete it with Benz by telling you that, because I have seen this pattern appearing many and many times, and a lot of advertisers bidding on Mercedes Benz together. So based on that, I can do the auto completion task. That was one of the things, but at the same time, I can also identify the ads which are specifically focused to this particular keyword that you're interested in, and show you just those ads. So that's where again you can use the concepts of unsupervised learning in a real world application. We were using it. Yeah, so exactly some of these things, like, okay, so again, a very funny example, but worth a read. That, okay, it says that this meatbag bought a sofa. Okay, so then eBay or Amazon would say probably he loves sofa. Let's recommend him 148 more sofas. It's very annoying. We see this from time to time, that Amazon recommends you a lot of things. Like if you buy a belt, it will also suggest you to buy a tie, shirt, and everything, which you not require. But this is how the recommendation engine works. That you have an underlying SVD based, or like a machine learning model which is there, which is telling what it should suggest next. So coming to reinforcement learning, which is the one of the final concepts that we'll be talking about. So yeah, reinforcement learning like has been there for some time, but it has become more popular of late with this entire hype about the self-driving cars. Companies like Uber, Tesla, Mercedes heavily investing in self-driving cars. You have a robotics field, like in medicine and in space agencies using robots. The concept primarily in reinforcement learning is that you have a machine or a model or a robot, whatever you want to call it. It performs an action, and this action is performed in an environment. And when this action is performed in an environment, the environment gives it a feedback of a reward. So this feedback allows it to the robot to learn that what action should it perform next, such that for the goal that it wants to achieve, that is the optimal action. So suppose that you are designing a robot which is supposed to not hit any obstacles. So when you design that robot, you give it a set of instructions, and you see for each of these instructions what is the action that the robot performs. So if the robot takes a forward step and doesn't hit the obstacle, it gets a positive reward, and if it takes a backward step, side step, and different kind of steps. So these steps which I'm saying can be the actions that the robot can take, and the reward would be every time when it takes a action, it doesn't hit an obstacle, it gets a positive reward, and when it hits a obstacle, it gets a negative reward. By providing this and modeling this, you can learn the trajectory. The robot can learn the trajectory that it should follow, such that it can avoid all the obstacles in the room, or whatever is the task that it is supposed to do. So this is what would be the example, or like a concrete example of reinforcement learning. And this is the exact principle that many of these self-driving cars are also trying to use. Then you have game companies like EA Sports and all, who are designing now FIFA, which is AI based. You have DeepMind, which came up with AlphaGo, which can like outperform the best Go player in the world by using concepts of in reinforcement learning and combining it with deep learning. In finance, in algorithmic trading and hedging, you can use it. So, for example, you perform an action. So you said that, okay, I will you do a put for buy, or you set to sell the stock, and you see what is the action that your model perform. When that action is performed, what is the feedback that you get? Is that whether the stock really should have been sold, it went high or down. Based on that, you can have positive or negative rewards, and when you have these rewards, you can then build the model, the reinforcement learning model, such that it can learn those trajectories that can lead to optimal rewards. And it is already being used for algorithmic trading and hedging kind of purpose. And then for resource investment, so resource management also, you have companies like Amazon, Microsoft, Google, Alphabet. They are all using this to allocate resources, like concepts of reinforcement learning also in those areas also. So in reinforcement learning, we have two particular types of approach. We have a model-based approach and a model-free approach. In the model-based approach, you need to memorize the trajectories. The model needs to memorize the trajectory that lead to optimal solution. Whereas in the model-free approach, the the model does not memorize any of the situations. What it does is that it has this exploration factor, because sometimes what can happen is that if you memorize situations, you can end up in a infinite loop, and you can get rewards, but the rewards are not always leading to the optimal result that you are interested in. And there are some examples of that, like funny examples in games, where you can get a lot of rewards, but you are stuck in a loop, and you're not able to achieve the optimal goal that you have. So you have to at that point, you have to have an exploration aspect also. So exploitation is about getting the maximum rewards, but you in reinforcement learning, you have the concept of exploration also, where you have some amount of randomness, that if you get stuck in a particular situation, you randomly select a negative action also, or you select an action which is not always going to lead you the optimal or the maximum reward, but a sub maximum reward, or can even give you a negative reward, but you try to explore other trajectories. And these kind of approaches have become more and more famous with deep learning. There are techniques like Q learning, SARSA based techniques, many techniques which appear. I don't want to go into details of that, but they have become more popular with in combination with deep learning, and can be shown to be as good and in terms of both convergence as well as the performance with model based approaches, while overcoming all the limitations that are there for model based approaches. So this is again an example. So one of the principles in reinforcement learning is that in order for it to work in this state action representation, state action reward representation, it has to follow a Markovian process. And this is exactly what we are showing here, that yeah, if you start at home, for example, and you go to work, and from there you go to bar and you come back to home, this is a good this is what is a Markovian process. But if you go to from home you go to bar, I mean, it's not necessary, you get a negative reward. So what it has to learn, I mean, the model has to learn is that what is the optimal trajectory here, that I should go to home, work, and then go to the bar and then come back to home, that would lead for the maximum rewards. So the states are your home, work, and bar. Your rewards are the edges shown with the positive and the negative values. and the action is that the path that you take, whether you go to the home or go uh, to the work from home or to the bar. So these are the actions that you take. An example is, for example, I'm showing here is of the Pong solver. Here you can see that this is a this the this is the computer playing it, and then this is the machine learning model that has learned such that the goal here is that every time it loses the ball, the computer gets a point, and then it has to beat the computer such that, I mean, it has the it wins the maximum amount of points. So here each frame is your state. When you build this model, each frame is the state, and the action can be that the ball can go up or down. These are the actions that it can take and the directions that it can go in. And your reward is that every time you beat the computer and you make the ball fall from the side of the computer, you get a positive reward. So build based on this, where this is learned through a deep learning model, deep reinforcement learning model. You can, I mean, yeah, there are these. There is open source code available for this. You can see that you have models which can beat the computer very easily. Coming to important problems in healthcare, so there are pharma companies which are using also to discover new drugs, and currently it's very important given that we are living in the COVID-19 era, that what pharma companies do is that you have drugs, you learn representation for the drugs, you build models. Once you have built some model, you get a representation for that drug in a form that a computer can understand, and then uh, you try to use this particular representation to generate new drugs by perturbing it, by adding noise to it, and then passing it through some deep learning models to generate new drugs. When you have generated these new drugs, you want to see whether they are efficacious, I mean, whether they are really uh, drugs that can be viable or not, and there are metrics for that that they can use. So these metrics are the actions for you. Your state is this generation state which is there. This is the state, these are the actions, and the reward are that when a drug that is generated is passes all of these different uh, qualitative criterias, you have a positive reinforcement that this can be a candidate for a new drug that can be used for treating a particular disease. So based on the principles of reinforcement learning in combination with deep generative models are also being used in pharma companies. So finally, the last concept that I would talk about is deep learning, and it's one of the most important concepts. Like deep learning is present almost everywhere we see right now in most of the machine learning products that you are aware of or are using. There is some form of deep learning being used. So deep learning, some applications are like object detection. So in your cameras, when you click a picture, modern cameras also have the facility to identify the faces which are there. This example is a very prominent example of object recognition using deep learning embedded in your mobile phone software. Speech recognition and synthesis, Google, Amazon, Microsoft, all of them are using it to come up with like Google Translate, Google Transliterate. All of these are systems which are using deep learning models for doing speech recognition and synthesis of speech also, or generating speech also. For people who cannot speak, they can use devices and then can generate speech. These kind of also products do use deep learning models for style transfer. So you can do a digital painting, you can transfer the style of Van Gogh to your photo, an image that you have taken. So you can use deep learning models for that. For deep fake, I mean, one of the disadvantages of deep learning model is that you can now have the face of someone, and you can make them mimic any of the things that you want them to say. And I'll give you an example also of that. It's a pretty interesting example. For machine translation also, like in Google Translate, I gave the example, deep learning models are being used by companies like Google. So yeah, to give you an example here, how does a deep learning model work? So you are given an image here, like this is basically the handwriting recognition problem that I was telling you. You are given an image of 4 here. So you have pixel information, every pixel information is there. You use this pixel information to make the input. Then this input is connected to what is called neurons, or the hidden layers with the comprising of neurons. very similar to what how our brain works, and all these networks are connected with weights, and then you have the outputs that you want to identify which particular digit it is. So what the machine learning model learns here is what are the weights that lead to what are these set of weights or connections that I need, what are the values of these connections that I need, such that I can optimally identify this for. And we have techniques like feed forward, feed forward approach and a backward propagation that allows the model to learn the optimal set of weights, such that you can correctly identify what particular character this is. So this is one of the most basic examples of deep learning. You have concepts of convolutional neural networks. So like the example that I gave about object recognition or your face recognition from your photos, you have an example of an image of a cat. And what convolutional neural network does is that it does not look just at individual pixels, but it looks at a patch of pixels, and based on these patch of pixels, it gets shapes. It learns lot of different information which is there in these pixels. It tries to combine this information. It has multiple such filters. It uses multiple such filters, and then the final thing is that it wants to identify whether it's a cat or a dog or whatever is the task that it has to perform. And all these weights that are again present in this network are learned through the deep I mean are learned through the process of forward training and then backward propagation. So two important key concepts in deep learning are these feed forward process and the backward back propagation. Using those only, most of these deep learning models work. You did not, the point here is that I'm giving you these brief concepts, just to make you aware what are the intricacies which are involved in that. But when you do your deep learning or machine learning courses, you do not necessarily understand all of them by heart. What you have to understand is that how these models work in general, such that you can, when you are posed with a new problem, when you're working for a particular product, it can automatically click for you that what particular model I should use for this particular scenario. And that can only click for you once you have an understanding of what does each of these model do. And coding is one component of it, but if you don't understand what would be the most appropriate model to use for a particular problem, that can lead to erroneous solutions. So you have to be aware of those kind. These this is why it is important to understand these concepts a little bit in depth. So yeah, this is just another example that from the faces, the different convolution layers they learn for other things, like they at the lowest level they learn about edges. From these edges they convert these edges into shapes. From these shapes it learns about the faces. So this is how these different layers of convolution works, and they learn different things. So this is the most of the advancement that happened in deep learning is because of the computer vision people. They were the ones who showcased that deep learning works very well for the problem. ImageNet was one of these challenges where the accuracies used to be pretty low. But then there was the AlexNet. There was a guy, Alex, he came up with the deep neural network based models from the 1980s. He trained it on GPUs and showed that he could achieve performance which was unheard of. And that what led to the resurgence of deep learning and led to the kickoff of modern AI with deep learning. Yeah, there's also the concept of recurrent neural network. So in speech synthesis or in speech recognition, yeah, when you speak something like say hello, what the neural network is trying to learn here is that what is the sequential information which is there in your phonetics or the alphabets which are there. When you speak each of these alphabet, it tries to learn what are the phonetics or what are the patterns associated with each of the alphabet when you speak them, such that, and in the sequence, such that it can synthesize new speech or it can recognize the speech itself. It can be both ways. The problem can be from the speech, it has to recognize what are the letters that you're saying. That would be translation problem. Here it's a synthesis problem. But the important thing here to understand is that it's a sequential information is there, that when you speak hello, it comes, H comes after E comes after H, L comes after E. There's a sequence information, it is there, and that is what recurrent neural networks exploit. Basically the sequential information they exploit. So let's give you an example of like deepfake. I was telling you.
Doctor, again, we are unable
Yeah.
to hear this.
Oh, you are not able to hear this?
Yes, yes.
Oh, okay. So what I mean, I will share the slides and you can look at it uh, later on. But I mean, yeah. So this is an example here. I show here just of like it is Obama's face, and it looks like he's saying those things, but he is not saying any of this. So this is an example of deepfake where somebody has put speech on his mouth. So combine the ideas of vision as well as speech and made a deepfake model to put words in the mouth of Obama, if I may say so. So yeah, I mean, this is just one example, but I mean, I will share this with you guys. You can all listen to it. It's a pretty interesting, interesting and at the same time a scaring application of deep learning also. So yeah, I mean, just final set of thing is that for deep learning you have different type of models which exist. You have models which are based on just the feed forward, deep feed forward neural networks. You have recurrent neural networks. So some of these neural networks are meant for sequence data. Some of these neural networks are meant for image based data like the convolutional neural networks. Some of them are are meant for generative modeling. So different kind of deep learning models exist. And yeah, I mean, when you will learn a machine learning course, you will become aware of most of them. um, that's a good machine learning course then, when it makes you aware of all the different kind of models which exist. So I hope, I mean, I made it clear to you that there are so many different applications, but just to reiterate that there are applications in banking, fraud detection, credit risk modeling, which fall in the category of supervised learning. In finance, you have strategy decision mark making, risk analytics, which can be both supervised and unsupervised learning. You have transport where you have enhancing safety of passengers, car monitoring systems, where you have applications from reinforcement learning, supervised learning, manufacturing, predicting potential problems, automating manufacturing units. Again, examples of supervised as well as reinforcement learning. In healthcare, you have drug discovery, virtual assistants, good examples of supervised and reinforcement learnings. And in e-commerce, identifying consumers, example of recommendation systems, recommending products of unsupervised learning here. So you see that this is really happening. I mean, there are industries which are heavily using all the ideas of machine learning. I hope I have made this point clear to people that the coming edge, in the coming age, we will be more and more reliant on AI-based technologies to solving from the most extravagant problems to our mundane tasks also. So all of this are, I mean, I hope are good enough motivations to for you to learn about deep learning, and I mean not just deep learning, machine learning in general. And then I just want to tell you that where as researchers we are at. So this is by Jan LeCun, who is a Turing Award winner. Uh, he's said to be, along with Jeff Hinton and Joshua Benju, one of the fathers of modern AI. These guys. So what he says is that uh, where what all things are we very good at? We are very good at supervised learning. So the machine learning predicts a category of a few number for each input. So we are very good at this is what he considers to be part of the like the icing on the cake. Like you are the icing on the cake is like supervised learning. Reinforcement learning, the amount of knowledge that we have right now is just put like the cherry on the top of the cake. But the real cake is unsupervised learning. There's humongous amount of unsupervised data without any label information. Getting labeled information is costly, it's expensive, it's difficult. So you have huge amount of unstructured data in the form of unlabeled data, and through the various websites or many of these platforms, social media platforms. So exploration of this part of the cake is what we are not very good at, and this is where we have to, as researchers, we have to focus a lot of energy on. This is what he's saying. I mean, he came up with this figure in NIPS 2016, which is one of the premier conferences for machine learning, and that's what I mean. A lot of machine learning researchers also agree about that the machine learning predicts any part of its input from any observed part. Like, so yeah, exactly. I mean, and he gives some examples also. Like, if I have information about the data, can I use it? Like, if I hide some part of the data, can I predict that hidden part of the data based on the other part of the data that I can see? So this kind of examples is what we are calling self-supervised learning, yeah, so new areas like self-supervised learning are being developed. So with that, I think yeah, I would end the part on the concepts and applications of machine learning in general. And yeah, I can give you like 5 minutes break, and you can, in this 5 minutes, you can like post questions and try to answer them before I go and finish off with the resources part.
Thank you very much, Dr. Raghvendra. It's very useful session, and I see that you are mostly focusing on the concepts and the application where that is applicable. So I think having the clear understanding is very useful before directly jumping into the coding part. So
People are using Python, and it also allows you to do documentation. You can also have notebooks which you can share with people. So the and of course the deep learning models are mostly made on platforms or libraries associated with Python, like PyTorch or Keras or TensorFlow. So you need to get accustomed with that, because that's where maximum amount of support is also available when you want to build your models. uh, Particularly if you want to use deep learning models and you have extravagant amount of data, uh, because technologies like Java and there Hadoop, also Spark Hadoop are also there, but for doing prototyping and also trying to make a product, it's better to use Python. The timeline and the number of people that you need depends on the kind of project that you want to make. So for example, when we do a project in bioinformatics, generally we are and we're trying to work on a problem particularly and try to get it shipped in the, say, the local hospital platforms which are there. We take 6 months generally to come up with a prototype. In between, we follow agile technologies, like agile methodologies, that we try to do the entire process couple of times, have our models, collect the maximum amount of time that it takes for us is about the data acquisition and like data cleaning part, which are not necessarily part of the machine learning modeling phases. But this is the part like where you spend a good amount of energy, and we need, generally our teams are small. If you are well versed with basic techniques of machine learning, you can work with 2 to 3 people or 3 to 4 people in a team, and that should be generally sufficient when you are trying to build a small product or you're trying to accomplish a small project. I hope that answers your question.
Thank you so much. I really appreciate for your answer. Currently working
Yeah,
for Infosys, I like the way you answered. Thank you so much.
yeah. I hope now the screen is also shared.
Yeah, it's I can't see your screen, but I see you on the now
Okay.
I'm able to see.
Yeah. Okay. Cool. Sorry. Yeah. So
uh, we can see your presentation, Dr. Raghvendra. So
yeah,
everyone, please post your. You can post your question on the chat window also.
yeah. If you post the question in the chat window, I can, and I can just finish off also. And then we can have the question answers if that is also okay.
Yeah, hello. Good morning, Raghavendra sir.
Yeah.
Yeah, myself, Ahmed Khan. I'm working as a business analyst, and I'm pretty much familiar with the data science and machine learning topics. But more often, I I'm thinking about the decision science and operation research. I'm more interested into those topics. I just wanted to understand which language is mostly preferred, as well as where we can get the proper tutorial, because I'm completely I'm surprised, I'm not finding any resource for those things. Kindly, can you guide me on those area,
Yeah,
linear
sure, sure.
optimization and linear programming?
So I think if you want to do a basic or a good course in general on things like programming, for programming there are many places. Like if depends on what kind of language that you are interested in. For doing Python in general, you can find. I mean, Python itself, and for machine learning in general, you can find lot of resources available on Scikit-learn. So Scikit-learn has classical and traditional machine learning information and tutorials which are there. I can try and find out some of these. I have not mentioned this, but this is a good question about what can be good programming platforms that I can share with you. I can try to provide you that. But for linear optimization or linear algebra in general, there is a very good course in Khan Academy that you can do. I mean, that's one of the prerequisites that I was going to mention. But I think, yeah, understanding basic stats, mathematics is very important for doing machine learning in general and linear algebra in general. So there's a very good course in Khan Academy that you can do. It's free, open, that you should, I guess, I mean, if you're interested, you should do.
Thank you very much, sir. Thank you for
Yeah,
your
no
answer.
problem. No problem. I will try to get more information on the programming part. That's something I missed, but I will. I mean, some of them are already in my slides. I will tell you in the resources part, but it's not necessarily related to linear optimization and computer programming. I didn't think about that. Yeah. Okay. So can you please suggest the module which I can use in Python which will clear my basic concepts in machine learning? So there are multiple modules in Python that you can use. For example, the most basic one that you have to definitely get a good handling and understanding on are the libraries like Scikit-learn, because in Scikit-learn you will find all the classical machine learning algorithms that I talked about. Then you can also you have to be familiar with how to wrangle data. So for doing that, you have to be good with understanding NumPy and Pandas. Both of them generally are very useful when you are managing your data. So be it structured or unstructured data. And for doing deep learning, you have to, I mean, learn about something. Either you can learn about keras and tensorflow, though I would not suggest that, because it's too abstract. The keras is too abstract and tensorflow is too low level. What I would suggest is a good compromise is something like PyTorch. PyTorch is it has a good community. You can see a lot of solutions for majority of the problems that you will face on Stack Overflow or other places. So PyTorch, and it has a lot of good tutorials itself also. So PyTorch would be what I would suggest. And then what is the question, sir? It's quite a deficit
Yeah,
to
hi
understand.
Raghvendra.
Yeah,
Can I ask a question? Yeah,
yeah, yeah, sure.
so Raghvendra, like I have close to 10 years of experience with respect to Apple, Google, and Facebook. India mostly with respect to machine learning, like identifying sensitive contents, working on Google Photos. And it's mostly like with respect to process excellence and operational experience, it mostly revolves around controlling precision and recall. I mean, the exposure
Yeah,
which I had with respect to managing teams and such that. But now, like when I feel that I should learn more about things, and understand the aspect of a programmer as well, such that I can understand the product in much more better way. How should I go forward? Like I started with learning R, probably Python. Is it a good way? Can you just share a small or a quick way to start with, to
yeah.
learn
So
that stage where a programmer thinks about?
yeah, I think I mean, first of all, congratulations on your tremendous amount of experience that you have, and
Thank you so much.
that's a great feat in itself. But I mean, what I want to say is that you need to be a hustler. You have to start from scratch, and in the sense that you need to if I am a programmer and I want to learn something, I mean, and want to start on a project, the first thing that I would think about is the language that I'm going to use, so such that I can code. And I can give you a very good example of some of the recent problems that we worked on. So we worked on a problem related to AML, which is acute myeloid leukemia. And in that problem, so what was there is that we were participated in this challenge, which is called Dream Challenge. And you have an organizer which basically provides you data, which can be an academic institution or a government institution. So in this particular case, it was the National Institute of Health in US, along with a couple of other institutions like Mount Sinai and all hospitals, which had data available for patients who are suffering from leukemia. And the goal for them was to identify drugs which can be which can prolong which can have the best therapeutic uh, response to these patients whose information, suppose we have genomic information, don't need to know the detail about it, but for whom we have some clinical information available, which drug would be the most suitable for this particular patient, and which particular and how long can I prolong the life of these patients. Because blood cancer is one of those cancers which are extremely aggressive, and it's very like difficult to treat also. A lot of mutations happen. So when we were given the data was coming in a tabular format, and as a hustler or as a project developer and like as a solution developer, we try to use not just we try to explore the data using R. So for doing exploratory analysis, something like R is very good because it has a lot of good libraries like ggplot, which allow you to explore very well. In Python also you have matplotlib and some other libraries which do allow you to visualize, but R is extremely good with respect to visualization. And then we pre-process our data, everything using R, and this was then fed to models, deep learning models, as well as scikit-learn models, which are built in Python. So it's not just one necessarily language. As a solution builder, I cannot just restrict myself to one particular language, but I can even use a combination of languages such that I can ultimately achieve the prototype and the solution that is desired. So I hope in part it answers the question that when you are trying to come up with a project, you don't need to necessarily restrict yourself with one particular language. Of course, it is very easy to manage when it is in one particular language, but it depends on the situation and also on the type of project that you are doing. So I hope that kind of answers
Of
some
course,
part of
thank
your
you so
question.
much. That was really
Yeah,
very much informative. Thanks a lot.
yeah. So there's a question about best model for fake news detection. Yes, so fake news detection also, yeah, we have colleagues at QCRI who are working on, who are like the pioneers in fake news detection. And they are using, for most of these languages models right now, they are based on deep learning models, particularly like LSTM, CNN, or combination, or even like CNN, LSTM combination based models, or even models which are ResNets, or even based on BERT. So there are many, these technology keeps on advancing, very rapidly, very fast. Like BERT, the example of BERT that I gave you is based on the idea concepts that you have huge amount of unsupervised data and unlabeled data, and you want to learn as much as possible from this unlabeled data that is there. And so the way that they do is that the example that I gave you about, you have documents, say you have millions of documents coming from Wikipedia, or yeah, like resource like Wikipedia. What they do is that they hide the context, or they hide a patch of the information in these documents, and then they use these BERT based models, deep learning based models, to identify what is the information that is missing in this patch of data. The goal of this is that when the model will become robust and will learn not just the semantics which is there in your documents, but also not just the syntax, but also the semantics which is there in your document. Now when you have a small data set, for example, now I have a new set of data for a particular task that I want to work on, I don't necessarily have huge amount of data. I can use this pre-trained model uh, and work on the problem that on the data that I have using this pre-trained model. So this is something exactly what they are using also in fake news. I hope that answers that question. So if uh, let me just come to the resources part, as I said to. So as I see that most of the questions are about the resources, and it is very important that when you are doing a course in machine learning or doing something learning about machine learning, or you want to use machine learning, you should be familiar with. And I am pretty sure that those who are in the tech field or who have done at least a bachelor's course in IT or even in technology, or like in computer sciences, they would have taken several of these courses. But it is for people who have not taken these courses, I would say that you should take a preliminary course in like mathematics, probability, linear algebra, and computer programming. All of them are available in Khan Academy. Very good courses. Several of them I have taken myself also, like because I always believe in the concept that learning never ends. So I keep on going back to the basics and take courses myself. And then you have resources like uh, for if someone was looking specifically for good courses in machine learning, I would definitely recommend the starting course of machine learning from Stanford, offered by Andrew Ng on Coursera. It's a free course as far as I know, but if you want to get the certification, you have to pay some money. When I did it was a free course. I did it back in 2012 or 13, but it is one of the best courses in machine learning that I've done, both from a practical aspect, but also as well as from, I mean, from a researcher perspective, but also from a practical aspect, like from engineer's perspective. That when you build your machine learning models, what kind of things you should take care of, like overfitting, generalization. Why does your model does not work well even when you have enough data? How to handle model complexity, but all of these perspectives from real engineering point of view, that how you can make scalable products and like products which work where the AI technology is very robust. You have also the course of machine learning with Python from MIT. So this is more for people who are asking about what kind of language that I should particularly focus on when I'm wanting to do machine learning and like learn about machine learning. So I would recommend that you do this particular course, like machine learning with Python, from MIT. And this course I have not taken myself, but the first and third course I've done myself. The introduction to machine learning for coders is from Fast AI. It's a very good course for people who want to learn about deep learning in more depth and like build fastly prototype deep learning models and get a good quick insight into deep learning. It's from University of Southern it's from University of San Francisco. Yeah. So people who are more interested in advanced courses, who want to do like a postgrad or want to do doctoral, who are doing doctoral degrees, or who want to understand the science behind machine learning, there are courses for them also that I would recommend. So for people who want to learn about classical machine learning, these are two good courses. Trevor Husty and Rob Tepshani are top-notch researchers, statisticians from Stanford University, and their course. I mean, the link here highlights the YouTube. They have YouTube videos associated with that. So I have provided that, and I will share the slides with the organizers, and they can share it around with the people, and they can basically then look at those YouTube videos and acquire more knowledge about this particular course. And there's also a very good course. It's a little outdated. It's from 2013. This one is from 2018, but this one is from 2013 from Nando Fries. He is a top researcher in Google DeepMind, and it covers all these aspects from classical machine learning to reinforcement learning in depth. If you are looking in particular a course on reinforcement learning, then I would suggest to take the course of David Silver. He is the pioneer in reinforcement learning. He works at Google DeepMind and got a PhD from Cambridge. Is an excellent course, and you will become very familiar with all the concepts involved in reinforcement learning. And for deep learning in general, the course from the machine learning course from Coursera is on general machine learning. But for deep learning, also Andrew Ng has a good course, and you can look at that particular course also. It's updated every year, and you can look at that course also. So, and also for people like us who want to know where is the latest technological breakthrough, or what are the latest models related to deep learning or any general machine learning model, we also focus a lot on uh, top primary conferences in machine learning. These are the International Conference in Machine Learning, ICML, Neural Information Processing Systems, NIPS, Knowledge Discovery in Databases, and International Conference on Data Mining. These are some of the top non-theoretical necessarily. I mean, they are theoretical at to some point, but at the same time, they focus a lot on technological innovation, engineering innovations coming in modern machine learning and AI. Finally, talking about languages and skills, yes. So traditionally, what we are taught when we are doing IT courses are things like Java, C++, .NET, and other things. But for machine learning, you need to be proficient in some other languages like Python, which has, and why in Python? Because it has support for a huge amount of libraries associated with machine learning. There's a very good community where you can find support for the problems that you're stuck with. You have to also be very proficient as a statistician with R. Again, it has, because of the same particular possibilities of inbuilt libraries to use. And then in both of these languages, it is very easy to share the code or the prototypes that you build to a wider audience using notebooks, markdowns. Both of them allow you that. And at the same time, you have to become a little proficient or understand concepts related to high performance computing, because most of the models that you will be building will be on GPUs, or you will be utilizing parallel computing power. Although Python and R have inbuilt libraries which can take care of it, multiprocessing, multi-threading for you, but it is good to be aware. And it is because of these modern high performance computing environments that we are able to build products for scale, and yeah, I mean, utilize it in our daily lives. Also, it's good to familiarize yourself with Amazon Web Services and Google Compute, because they allow you to utilize very cheaply and efficiently. If you are trying to build a startup, they already have packages where you have pre-installed Dockers and environments for performing all your machine learning modeling. Given you just provide the data, and you can utilize all the inbuilt libraries which are there, and the programming language that is of interest to you at a very cheap cost, I guess. Yeah. Finally, how to highlight or how to become more prominent, even if you are a bachelor student and you want to highlight it in your CV, that what kind of things that you have done, such that you can stand out a little bit. You should participate in real world competitions, and Kaggle is an extremely good platform for that. It allows you, like Top Coder, Spodge are for coding people who want like to do coding competitions. Kaggle is that for data scientists and for machine learning enthusiasts. That they have real competitions. You participate with tons of other people, and if you stand good, you can always highlight that in your CV. Recruiters love to see and that you have participated in such competitions. Then you can make your projects available open source. That allows you highlight to the world that you have created code which is can be used openly in an open environment, and at the same time you get stars and feedback on your repositories. You learn from people, and you learn from you I mean, people can reuse your code, or you can reuse other people's code. You don't need to necessarily build everything from the scratch. So, and that also like gives more power to your CV when you can have a GitHub page and highlight all the repositories that you have developed. And of course, you when you work on a project and it is successful to any extent, and you have learned something, you should write articles on LinkedIn or Medium, such that you can highlight and people can learn from your experience. Many of the slides that I have presented here are taken from blogs and blogs of people, and articles written from Medium, and not necessarily written everything myself. So why not reuse all the resources, and why not make the knowledge that you have gained available for everybody else in a simplistic manner. So with that, I guess, yeah, I feel like, yeah, these are all the things that I wanted to cover. I guess I have exceeded my 2 hours, but yeah, I'm happy to take any questions that you have.
Thank you very much, Dr. Raghvendra. Extremely useful session, and we are very thankful for your valuable time. So, participant, please post your question on the chat window. We do see some technical glitch happen due to this. The session abrupted 20 minutes ago. Due to that, less participants are there right now. So, please feel free to write your question in the chat window.
So, hi, Mr. Raghvendra. Thanks for your valuable time and valuable session. I have a question. Uh, when you say like uh, uh, supervised learning and then supervised learning comes with cost. So, what are
Yeah.
the areas that actually makes it cost? Because other than the labeling the data, so what are the different uh, challenges we have for to label the data other than man force or any amount, or just if you can highlight those areas, it will be helpful. Thank you.
I mean, so that's a very good question. I mean, that what are the things which are difficult for supervised learning in general? So I mean, if you look at, if you just remember the slide that I presented, where I said that supervised learning is the icing in the cake. We have made the maximum progress that we could in the area of supervised learning only. So all of classical machine learning, the major advancements that have happened have been in the area of supervised learning, because of the, I mean, availability of data which was labeled and which is labeled. So labeling is one of the primary costs which is there, apart from manpower, but it also is money. It costs you a lot of money. For example, in the case of drug discovery or in the case of the drugs, like every drug that you test in the lab, it costs thousands of dollars. So there's a cost aspect associated, not just with from the manpower but from the resources point of view also, in terms of the amount of money that you need. Apart from that, it is sometimes very hard to get labeled data. Like, you cannot label sometimes the data which is there. If you have geospatial data, you cannot label that, and you cannot pose the problem as a supervised learning problem. So that can be also a difficulty which is there.
Thank you, sir.
Yeah.
I think Dr. Raghvendra, we are done with the session,
Yeah.
and I would request the participant can always reach out to Career Guidance Council team for any queries. We'll connect you with the Dr. Raghvendra going forward, and we are so much thankful to Dr. Raghvendra for his valuable time and such an insightful session on machine learning, and we look forward to have many more such useful sessions. Thank you so much again, sir.
Yeah, thanks once again to Career Guidance Council. You guys are doing amazing job by providing these webinars to people, and it's great to be part of this. And I'm extremely happy for any other further questions that you have. There might be some question that I might not have answered appropriately. If I find some more answers, I will try and reach out to the organizers and try to provide more concrete answers.
Yeah, sure. Thank you so much. So with this, we conclude this session. Thank you all for joining.
Yeah, thank you.
अरे मीटिंग इज प्रोग्रेस प्रोग्रेस बोले हाँ क्या करूँ यू आर अनम्यूटेड हाँ पहले म्यूटेड बताया तो मैं क्लिक करा अनम्यूटेड बता रहा तो लीव कर दूं live meeting leave meeting are you sure you want to leave the meeting